Okay, good morning, everybody. It is the last day of school for this year. I mean, really, come on, it's like of 2020. We're done, okay? So Friday, 12/18. So section 8, or excuse me, section 9.3 talks about this kind of triangle. So we look at this kind of triangle, and I just drew it out. It turns out that this right triangle, if I draw it correctly, with its altitude, that's its altitude, altitude's the height, right? It turns out that if you draw the altitude, which makes it 90 degrees, you end up with, really, three different right triangles. You've got the big right triangle, and then inside you have a medium-sized right triangle, and I redrew this one in the same orientation. So I put the 90 degrees, the D here, and I put the angle B, and then I put C up here. And then I also have a little right triangle inside of the big triangle, and I redrew that one too, so that I've got the 90 here, D, and then A and C. So if I take a look at all three of these triangles, the big one, the middle one, and the little one, they're all similar. They're similar by angle similarity theorem, okay? So because they're similar, then we can say that they're proportional. For instance, this side goes to this side. This side goes to this side. This side goes to this side, or this side goes to this side, or this side goes to this side, or this side goes to this side, okay? Now, if you can pull these apart and redraw them, then you get all these ratios, like, AC goes to CD as probably AB would go to CB. That's just one of the many ratios. You could even say something like this. You could even say that DB, that's this side, goes to this side, DC, as, so this side goes to this side, as maybe this side, CD, goes to maybe AD, okay? All right? If that's the case, then you can pull these triangles apart and set up the ratios. It makes it really easy. However, pulling them apart's not that easy. So the book likes to give us a little formula, okay? They say if you, instead of pulling it apart, there's these little formulas, okay? So here's the altitude. You can see CD. So I'm going to say CD squared, or the altitude squared, is equal to, well, this is hypotenuse, right? But it's got the parts. So the altitude is equal to this one part times this one part, okay? And we're going to do a couple of examples like that in our homework, okay? This one's a little bit different because they don't talk about the altitude, but they talk about the legs. So this is legs of a right triangle. And they'll say CB, so the leg squared, CB times CB is equal to DB, which is the part of the hypotenuse, times the entire hypotenuse. Or the other leg, you've got this leg, AC, or the leg squared is equal to AD, which is this part of the hypotenuse that's attached to the leg, times the entire hypotenuse, okay? So let's flip the page and let's take a look at that, okay? So in your homework today, first of all, number 1 and number 2, I want you to just draw out the three triangles. Just draw out the three triangles. Just redraw them like I did, okay? So I want you to redraw these triangles like I did and put them side by side. The geometric mean is just simply 2 times 6, and you take the square root of it. That's the geometric mean, because it's like 2 over x equals x over 6, and you'll get x squared equals 12. That's how you do a geometric mean, okay? Now 5, let's see, 5. Well, if I turn it upside down like this and look at 5, there's 5, that's my altitude, right? And I have a formula that says the altitude squared, it's going to be my x times x, altitude squared is equal to the part of the hypotenuse times the other part of the hypotenuse. Okay, and I'll let you solve from there. 6, that's a leg. Okay, so the book says if you use their formula, they're going to take the leg squared, or y squared, is equal to the part of the hypotenuse that's attached to it. That's the 9 times the entire hypotenuse. The entire thing is 11, okay? And I'll let you guys figure out how to do the rest of these, okay? So that's your homework. It's going to be 1 through 8. And then this isn't due until next year. Monday after evening of whatever, January 4th, okay? All right, have a wonderful vacation. I'll see you when you get back.